So 4.4, the quadratic relation, y equals a bracket x minus h bracket squared plus k. So the equation of a quadratic relation in vertex form is y equals a x minus h squared plus k. This is specifically vertex form because you're able to look at this equation and pick out the vertex. So the vertex is actually h comma k. Remember, there is a built-in negative sign in this equation. So whatever this looks like, if it looks like it's negative, it's actually positive. Okay? So opposite sign there. You can write that down. Okay? So example 1, graph the relation y equals 0.4 x plus 1 squared minus 2. Okay? So if you remember, the first thing you want to do is take this h value and you want to plug it in to this middle box right here. This is going to be our vertex. Instead of being plus 1, we're going to do minus 1. And going down, we're going to go smaller numbers. So -1, -2, -3, -4. And then we put bigger numbers. Okay, we count up. -1, 0, 1, 2. And then what you want to do is you want to go down this column and you want to plug in 0.4 bracket, plug in the -4 right to where the x is, plus 1, squared, minus 2. Then we're going to do the same thing, 0.4, -3 plus 1 squared minus 2. We're going to do the same thing, 0.4, -2 plus 1 squared minus 2. 0.4, -1 plus 1 squared minus 2. And you go all the way down. Okay, 0.4, 0 plus 1 squared minus 2. 0.4, 1 plus 1 squared minus 2. And 0.4, 2 plus 1 squared minus 2. Okay, if you put this into our calculators, we're going to get 1.6. We plug in -3, we're going to get -0.4. Plug in -2, and we get -1.6. This time is -1.6. And we get -2. And then this time, we should be going back up. Okay, we get -1.6. We get -0.4. And then we get 1.6. Okay, you're going to be able to see this symmetry right here as long as you have centered the vertex. So as long as you've put the vertex here, you're going to see the symmetry. Okay, and now let's graph. -4, 1.6, -3, -0.4, -2, -1.6, -1, -2, 0, -1.6. And if you can see, this is already symmetric, right? These are equidistant from that axis of symmetry. And then it's going to be 1, -0.4. And then 2, 1.6. Okay, so there's our graph. Y equals 0.4 x plus 1 squared minus 2. So just identifying some key characteristics of this graph. The axis of symmetry goes through -1. So that's x equals -1 is our axis of symmetry. And this point right here, which is -1, -2, that's going to be our vertex. Okay, example 2. Describe the graph y equals -0.2 bracket x minus 3 squared plus 5. And then sketch it using the vertex and 2 other points. So this one's going to be a little bit different because we're going to do vertex and 2 other points. So vertex. In this equation, we can identify the vertex, which is h, k. because the h looks negative, it's actually positive, right? That one flips sign, and then the k is 5. So we can go ahead and graph that, 3, 5. This is our vertex. This opens down. You should be able to identify this a value if it's positive or negative, right? So is a positive or is a negative? Well, it opens down, so our a value is negative, okay? So it's going to be a sad face. It's going to look like this. And when we look at a parabola opening down and the vertex being here, is this vertex the maximum, so the highest, or is it the minimum, the lowest? Okay, this for sure is a maximum. Okay, if you want to make a little note, if the parabola opens down, it's always going to be a max because it's always going to look like this. If the parabola opens up, it's always going to be a min because it's always going to look like this. Now, is our graph wider or skinnier than y equals x squared? What this is basically asking is wider would be a compression and skinnier would be a stretch. So if we look at the a value, which is 0.2, this is a compression, vertical compression, so it's going to be wider than the original. Remember, y equals x squared is the original graph with no transformations. Okay? Now, 2 other points on the parabola. What we want to do is we want to take a look at this x value. So we have 3. Okay? So let's go y equals negative 0.2. Okay? So we want to choose a point that is maybe to the left of 3 and then to the right of 3. So if we look at 3 on this graph, a point to the left, usually what we do is two numbers to the left and then 2 numbers to the right. So let's go ahead and sub in 1. So 1 minus 3 squared plus 5. Oops. Okay, if we put this entire thing into our calculators, we're going to get 4.2. So our point will be 1, 4.2. Okay, the other one, if we go 2 values to the right and we sub in 5, y equals negative 0.2, 5 minus 3 squared plus 5, we also get 4.2. Okay, so 5, 4.2, it's going to look like this, and this is going to be our parabola. So a little bit different of an approach to actually graph it. This time we graph the vertex and 2 other points. These points are symmetric. So identifying some key features here. The axis of symmetry is right here. It's at x equals 3, right? Remember, it's always going to be the x value of the vertex. And these 2 points here are equidistant away from the axis of symmetry. That's why they yield right here the same solution. Okay, so parabolas are symmetric. So the axis of symmetry which we just saw in the last 2 examples, intersects the vertex and is a vertical line. So it looks like this. It's a pretend vertical line though. That's why we do dotted. Okay, where the right side and the left side of the parabola are the same distance away from that axis of symmetry. We usually write AOS. So if you plot a point here on this quadratic, there's going to be another point that exists same distance away at that same horizontal. Okay, so there's our formal definition and example of axis of symmetry. Okay, so example 3. Consider the following parabola. So I gave you a graph of a parabola, and I want you to find the coordinates of the vertex and the values of h and k. So the coordinates of the vertex would be, if I identified it, I would say that it's right here. So this number between 2 and 4 is 3, and then -6, right? So the coordinates of the vertex are 3, -6. So 3 is our h, and -6 is our k. Now let's identify the coordinates of the two other points shown. So I put the two other points shown, any of the points shown. I'm going to see if something lands right on, right on the grid. That's the only way we can really do this. So I'm going to say possibly here. I don't like how that's between. So we could use these ones, or we can use these ones here, okay? But when I'm identifying these, I'm going to use the ones that are across from each other. So let's use these ones, okay? So this one I'm going to call 1, -4. And this one I'm going to call 5, -4. Okay? Oh, I can just write them here. 1, -4, 5, -4. Now, I'm going to ask you to find the equation of the parabola. So I put the steps to find the equation right here. So if I give you a graph and you know the vertex and two other points, even one other point, okay, you can find the equation of the parabola. So what you always want to do is you want to first write, so step 1, you want to write out y equals a x minus h squared plus k. This is the equation in vertex form. Okay, it's a quadratic equation. Now, what we want to do is we want to sub in the h and the k. So for h, we're going to have 3. For the k, we're going to have -6. And we're going to sub in an x and a y. So we have to choose. Do we want to use 1, -4 or 5, -4? You only have to use one of these points. So let's use 1, -4 because it's a smaller number. Okay, so the 1 is the x and the -4 is the y. Okay, and now what we're going to do is, so we've done 1 and 2. Step 3 is we're going to solve for a. So bring down this -4, bring down the a. 1 minus 3 is -2 squared minus 6. Then we're going to have -4 equals, what's -2 squared? It's 4. This is going to look like 4a. I'm going to switch the, instead of a4, I put it as 4a, and then -6. Okay, let's bring that -6 over, and we're going to get -4 plus 6 equals 4a. -4 plus 6 is 2 equals 4a. And remember, we always divide by the number in front of our variable. So we're going to divide by 4. So our a value is 2 over 4, which is 1/2. Now, step 4, we want to rewrite the equation of the parabola. So y equals 1/2 x minus 3 squared minus 6. We want to sub in our a value, we want to sub in our h, and we want to sub in our k. Okay, and we can cross-reference this with the graph. We see that our vertex is at 3, -6, and we see that our a value is positive, so we open up, and we can cross-reference that, and that's exactly how the graph looks.